Module 5 is really, really important for laying the groundwork for the semester. So module 5 is introducing what the sine function and the cosine function are. And I know that that activity was super long and I acknowledge it, but part of the reason why is because those really are foundational concepts and ideas for really the rest of the semester. Modules 6, 7, and 8 are probably the hardest modules of the semester. I would consider just a lot of heady things to make sense of. And so module 5 is really important. So if you kind of like burned out on working through the activity or you skipped the CYU, I would encourage you to go back and take the time to work through it. I'm just going to take a minute and talk through a couple minutes and talk through just a couple of the ideas real quick. So one thing is, and I know it's elsewhere in the module, but just to hit it again, right? So this sine function is going to input our angle measure, right? So we're looking at our angle measure. It doesn't matter if you're in radians or degrees. It does matter that the sine function defines as our initial ray, that 3 o'clock ray. Oops, can't spell. 3 o'clock ray, right? And so that 3 o'clock ray is our initial ray. And then again, just somebody decided years and years and years ago that sweeping out counterclockwise is going to be a positive angle. Sweeping out clockwise is going to be a negative angle. Now, the truth is sometimes we're not going to care. Like sometimes I only care about the openness of this angle. So sometimes I don't really need to make it negative. I just care about the openness. But if you see a negative on an angle, or if you are wanting to use the sine function or cosine function and get an angle that's like down here, then you need to make sure that it's negative. All right. The output of the sine function is that vertical distance above the horizontal axis in radius lengths. I'm not going to write all of that out, but for me, one of the biggest pieces is understanding that the units there are radius lengths. So, for example, let's go over here. So this is my unit circle. A unit circle really is just a circle with a radius of 1. So as I sweep out my angle, right? So as I sweep out this angle, we can see that that vertical distance is changing, that purple dotted line. So when I do that, let's say I stop here. So that would say that my angle is 2.25 radians, so that angle right there. So when we sweep out an angle of 2.25 radians, we are now looking at our vertical distance, which is that line. So just visualizing it, looking at it, we can see that that line looks to go up to about like seven, just under point 8, so 0.77 or something like that, 0.78. So the sine function would say when you input an angle of 2.25 radians, that vertical distance is 0.78, let's call it radius lengths. All right, so we would say 0.78 radius lengths, or another way of saying it, let's see if I can remember this. So the sine of 2.25 is equal to 0.78, I'm going with. So when we sweep out an angle of 2.25 radians, then that vertical distance above the horizontal axis is 0.78 radius lengths. Another way of putting that is we could say that that vertical distance is 78% of the length of the radius. The length of the radius. Because sometimes we can think of percent a little bit easier. So one kind of cool thing to note, so I guess when we're on our unit circle, so when our radius is 1, then that 0.78 is the same as our y coordinate. But that's only true when we are on a circle with a radius of 1. So if my circle is bigger, so let's say I take my circle and I increase my radius, right? So I increase this radius, and I know we're not going to be able to see everything, right? But I can even zoom out a little bit more. So if I increase my radius, that vertical distance is going to increase, right? This purple line got bigger. But the cool thing is that vertical line is still 78% of the length of this radius, right? So we say that that vertical distance is 0.78 radius length still, or 78% of the length of this radius. Now, the y coordinate is no longer 0.78. The y coordinate is 78% of this radius. So we could find that y coordinate by doing 0.78 times our radius is now 2.7. And I've rounded it a little bit, but that's going to be the idea. So that it's still 78% of my radius, which is now 78% of 2.7, and that y coordinate is 2.101, 2.106, just because of rounding. So that is why we use, kind of coming over here to the left side again, right? So this, the y equals r times the sine of theta to always find our y coordinate. So if my radius is 1, it just simplifies back to this. But when we are trying to find our y coordinate, we need to scale that vertical distance from radius lengths into whatever our units are by like stretching out our circle. Another couple, like another comment I remember reading was like students are like, when do I use the sine and cosine? So we are going to use sine and cosine whenever we are trying to find a vertical or horizontal distance. That might be an x or y coordinate, or when we get to Ferris wheels, we're looking at like vertical distances. So if I saw vertical, I would think sine. If I see horizontal, I'm going to think cosine. Another thing to remember is the other day in like module 4, right, we had something that was like S equal theta R. I don't even know where, like, right, theta times R. So that we would use when we are either trying to find an arc length or we are trying to, right, we're trying to find an arc length when we have an angle, or when we're trying to find an angle when we have an arc length. And so those are really like our three big formulas right now. So like these three kind of here at the bottom. So those are ones we are going to, no, that's not the third one. The third one would be like x equals r times the cosine of theta. Um, so those are the ones that we're going to come back to over and over and over again. So make sure you have those highlighted somewhere. Make sure those are ones that you really understand. So hopefully this helps you out a little bit, brings a little bit of clarity. And yeah, if you have any questions, don't hesitate to reach out.